We want to welcome you to the Dallas Independent School District STEM Environmental Educational Center virtual field trip. We want to say a very special welcome to Gilbert Cuellar, L.W. Kahn, and Mata Montessori, all of the Dallas ISD. Thank you so much for joining us on this winter morning. If you're watching teachers and you have not signed up, please do so. Go to www.tiny.cc/PK-2 restoration. We'd like to have you on our sign-up machine, sign-up sheet. Pattern of objects in the sky will be the program this morning. During this virtual field trip, students will observe and describe patterns of objects in the sky, including the appearance of the moon. Ms. Ramirez will tell you all about the day and nights. Seasons will be covered with Mr. Monroe. Ms. Schramm will talk about the moon, and Mr. Dominguez about the sun and the stars. Teachers, students, you cannot ask us questions during this program, but you can go to www.tiny.cc/questions-answer, fill out a short form, send it to us. I'll be glad to answer them if I can online. If not, on the program. If not, I'll send the answers to your teachers and they can go over them with you. Thank you. Now I'm going to stop sharing my screen. And Ms. Ramirez is going to tell you all about day and night.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning all about day and night. Before we get started, I do have an animal friend, and he represents an animal that is active during the day. So he is what we call diurnal. That means that he is active during the day and asleep at night, very much like us. So I'll give you some clues to who this animal is, and then I'll let you guys guess. This animal has 4 legs, a long tail, dry, scaly skin, and a beard of skin underneath his chin. Again, he is diurnal, meaning he is active during the day. If you guys guessed a bearded dragon lizard, you would be correct. Here is Spike. You might have met him before. Of course, he gets that name because he has a big pouch or beard under his skin, and he has spikes on his body. Again, he is a diurnal animal. So I'm going to go ahead and put our friend Spike up, and we'll start our presentation all about day and night. So I'm going to share my screen with you guys. I do have a couple of focus questions for y'all. Hopefully by the end of this presentation, you guys will be able to answer these questions. And the first question is, what are characteristics of day and night? And the second is, what causes day and night? So take a look at these 2 pictures. What do you guys see? Do you think it's day or night, and why? So how do you know? Now I'm going to go ahead and just jump right into it, but teachers, feel free to pause the video to allow time for discussion. Now I, of course, know and I noticed that I see a bright, shining sun. So hopefully you guys were able to find that sun. I also see some clouds. So not only did we have the sun out, but we also had clouds. And I also happen to see the moon. So I can see all of these things during the daytime. So we have our sun, clouds, and the moon. Now it's important to note that the moon is not a star like our sun. So the moon doesn't actually create its own light. We are able to see the moon because it is reflecting light back from the sun. And of course, we know that these pictures were taken during the daytime. So those are characteristics for day. Let's take a look at these next 2 pictures. What do you see? Do you think it's day or night? How do you know? Again, feel free to pause the video to allow time for discussion, but I'm going to go ahead and go right into it. The first thing that I noticed are lots of stars. In fact, I even see a pattern of stars. This is called a constellation. A constellation is just a pattern of stars, and this one happens to be the Big Dipper. I also see something nice and bright. I see the moon. So remember, the moon does not make its own light. It's just reflecting light from the sun. And it's easier to see during the nighttime. We also have our dark sky. So because of these characteristics from these pictures, I know that it is nighttime. Now we're learning about day and night because it actually affects the animals that we're going to be seeing today. So in this next little slide, we're going to be playing a game. We're going to see if you guys can guess if these animals are diurnal. Diurnal means they come out during the day, or if the animal is nocturnal, meaning they come out during the nighttime. So take a look at our first animal, the owl. Do you think the owl is diurnal or nocturnal? So when are you guys going to see owls or maybe even hear them hoot? Hopefully you guys said they are nocturnal. Now, the easy way to remember what these words mean is diurnal starts with a D, just like day. Nocturnal starts with an N, just like night. So owls are nocturnal or nighttime animals. Now let's look at these super cute raccoons. Do you guys think these guys are diurnal or nocturnal? And how do you know? Now, lucky for me, I used to live in Dallas and I actually used to see a lot of these guys in our backyard eating trash and leftover dog food. These guys are definitely nocturnal. So they are active during the nighttime. My last animal are cute little squirrel friends. Do you guys think they are diurnal or nocturnal? So when are you most often going to see squirrels running around? Hopefully you guys said they are diurnal. They are active during the day. You're usually going to see the squirrels running and eating during the daytime. So my next slide is a quick little video to help model what causes day and night. In this model, we're going to learn what causes the day and night cycle. I happen to live in Dallas, Texas, and I have Dallas, Texas marked on our globe with this orange dot. So notice the position of planet Earth. Notice where I am currently located, and notice where the sun is. So if I live in Dallas, Texas, which is right here, do you guys think it is day or night, and why? Feel free to pause the video, teachers, to allow time for students to discuss, but I'm going to go ahead and jump right into it. Hopefully you guys said it is daytime on this side of the earth because this side of the earth is facing the sun. So the side that is facing the sun will be experiencing their daytime. Now look at this side of planet Earth. The people on this side of the planet are experiencing their nighttime. So we have daytime on this side of the planet, nighttime on this side of the planet. Now our Earth does something very special. It rotates. Rotate means to spin. So our planet is going to rotate. So here I'm going to rotate planet Earth. Notice it's moving around. It's rotating, rotating, rotating. It's going to keep rotating and rotating and rotating. And now notice where I am located in Dallas, Texas, the dot is now on this side. So do you think Dallas, Texas, for this model is experiencing day or night? And hopefully you guys said nighttime is represented for this model for Dallas, Texas. It's facing away from the sun. So when the side of the planet is facing away from the sun, that is nighttime. So the planet is going to continue rotating or spinning. It's going to spin, spin, spin. It's going to keep on rotating, and we're going to stop there. Now notice Dallas, Texas is right here. It's facing the sun again. And so now we have daytime. It takes 24 hours or 1 day for the Earth to spin all the way around one time. So again, rotation just means spinning, and it's that rotation that causes day and night. This is a little song to help you remember rotation. Feel free to stand and follow along with me if your teacher allows. Otherwise, just stay in your seat and listen. If you're going to follow along, make sure you stand, push your chair in, and then we will get started. We are going to spin around And you guys are going to repeat after me. Rotation, rotation. Let's talk about rotation. Let's do it one more time. Rotation, rotation. Let's talk about rotation. Here's our next line. Causes day and night and the sun going across the sky. Repeat one more time. Causes day and night and the sun going across the sky. Here it is all together again. We're going to start with rotation. Rotation, rotation. Let's talk about rotation. Causes day and night and the sun going across the sky. Okay, I'm going to go ahead and stop that there, and I'm going to stop my screen share, and that is all I have for you guys today on rotation and what causes day and night. We're going to give it back to you, Dr. Gorman, to answer any questions.
Thank you, Ms. Ramirez. And one student wants to know, what is the longest day of the year? And that is June the 21st, and it's called the summer solstice. And now, Mr. Monroe is going to tell you about the 4 seasons.
Good morning, everyone. Wow, I've got a little help going on at the back of my lab this morning. He's saying good morning also. And that's old Smokey the Rooster. But listen, we're going to be looking into the special times of the year when we can notice maybe the temperature changing as the days go by, or even the kind of weather we're having, whether we're getting rain or whether it's dry all the time. And then one more important thing that happens as these very special days come along, and that is the amount of daylight that we have during the days in those very special times. Those very special times are referred to as seasons. So we're going to be looking at the seasons. And as I go through my presentation, my part of your virtual field trip today, there's a couple of things I want you to make an effort to remember, especially the order of our seasons, simply because your teacher may ask you later on if you can name the seasons and put them in the right order. Or they may even ask you, or take, for example, the season of summer. They may ask you what comes after summer. So hopefully I'll be able to help you remember the order of the seasons and how and why seasons happen. And to help me do that, I'm going to be using a short PowerPoint, and then I'm going to use a model, and then I have an animal that's going to help me to let you know that seasons have an effect on animals that live in nature. So let's get started. I'm going to share my screen with you guys. There he goes. He's really talking this morning. He's really wanting some attention. The 4 seasons. Wow, there's 4 of them, guys. So when we talk about the 4 seasons, we're actually looking at a season as one of 4 periods in a year. Now, I don't know whether you guys realize that or whether you remember this, but there are actually 12 months that make up a year, right? Now, each season lasts about 3 months. In each season, there are changes in the temperature, how hot or cold it is daily, and the weather, whether we're getting rain or snow or dry weather, and then also the length of daylight during the day. Now, believe it or not, there are some days in the year that, boy, we consider those the shortest day of the year. We'll talk a little more about that later on. Why do we have seasons? Well, it's basically because of the Earth's position in relationship to the sun, or in relation to the sun. You see, the sun, the Earth, and our moon, we have a very special relationship that goes on. And most of it is because of the action and the distance that each of these objects are from each other. The seasons change as the earth moves closer or further away from the sun. Now, why? Why does that happen? Well, listen, to kind of help you understand it, I want you to realize this. There are some places that are close to the center of the earth, near an imaginary line that separates the top half of our planet from the bottom half of our planet. And that line is called the equator, okay? These places do not move closer or further away from the sun. And because of that, these places stay very warm all year round. So there's not a big change in temperature. There's not a big change in the type of weather patterns, and daylight hours basically stay about the same. Now, what are the four seasons? Well, I think you guys probably already know that. Autumn, winter, spring, and summer. And the pictures or the images that you see on the screen kind of represent each of those seasons. We know that in autumn, that's a time that we have to rake leaves. And when winter comes, a lot of people are fortunate enough to get a little snow. They can build a snowman. And in the spring, we know that that's a very active time for the animals, especially young animals being born. And then, of course, in the summer, we know what happens then. Well, let's talk about autumn. You know, autumn is one season that also has another name. Autumn is also called fall because the leaves fall from the trees. In autumn, the leaves turn colors of red, yellow, orange, and brown. The weather begins to turn colder in autumn, a little cooler. And you know, autumn is a season that follows summer. And the summers that we have here in North Texas can get very warm. In fact, they get hot. And so a lot of people look forward to the cool weather that is associated with autumn or fall. Fall or autumn is one of my favorite seasons because it's not too hot and it's not too cold. Now, when winter comes along, boy, we get the coldest temperatures of the year. In fact, winter is the coldest time of the year, okay? Snow falls in the winter, and you know what? Wow. I heard the announcement the other day that we're not going to have school tomorrow or Friday, and that's simply because they're expecting some snow to fall and even some ice to be covering our roads, which would make it very unsafe for travel. So that kind of tells us what season are we in now. Ponds and lakes freeze in the winter, and because of the air temperature that's going to be very, very, very cold, it's going to be below the freezing point for water. And I'm anticipating, or I'm thinking that our little pond that's left over, what little water that is still in that pond is probably going to freeze. There will be some ice in our pond. You know, winter is a season that has a very special holiday in it. And a lot of people, in fact, I will say most people, look forward to this holiday, and that is the holiday of Christmas. Now, you know, after this cold season, people start looking forward to it warming up. And spring is the season that starts happening in. In the spring, we get lots of rain. Boy, do we need some rain. We have been pretty dry for a long time. In fact, they're saying we're going to start getting a little rain today before it gets too cold. Flowers begin to grow in the spring. The leaves begin to grow on the trees. The weather starts to get warmer. And I'm sure a lot of people are looking forward to that, especially in the northeastern part of the United States. In fact, this is another one of my favorite seasons because, again, it's not too hot and it's not too cold. Now, listen, guys, what comes after spring is summer. Summer, wow. It is considered to be the warmest time of the year. In fact, I would probably replace that word warmest and I would put the word hottest time of the year because we get very hot here in North Texas during the summer season. Water gets warm and so everybody can go swimming. A lot of families take vacations and they spend a lot of time at the lakes, and the kids and family, they get to go swimming and do other water recreational activities. And it's most important that you be safe when you are doing those water recreational activities such as swimming and boating. There is no school in the summer unless you have to go to summer school. And let's hope that you all don't have to go to summer school, okay? It's an excellent time for taking a vacation. Now, there are a few class activities that I want to mention that maybe your teachers will have you doing some of these. One is your teacher might ask you, well, what are some clothes that we wear during each season? And hopefully you'll be able to tell them why if they do have you do that. And then they may have you draw a picture of the things that occur in each season. That'd be nice. In which season do these holidays happen, like Halloween and Easter and Thanksgiving? And that last holiday, man, I still haven't had a chance to look up the day that day is celebrated, nor the month. So I'm going to have to do some research to find out what season Remembrance Day happens in. Now I'm going to stop sharing my screen with you guys, and I've got a model here showing the relationship that goes on between our sun, the planet Earth, and even the moon. But we're not going to talk about the moon because that's going to come later. But the sun is the center of our solar system. And Ms. Ramirez talked about our planet spinning, right? Rotating. Well, I got another word for you, and that is the word revolving, because what causes the seasons is the fact that our planet, the planet Earth, is tilted at an angle. It doesn't set straight up where the North Pole is at the very top, straight up, or the South Pole is down below, straight down. They set at an angle, and that angle never changes, okay? And as our planet, the planet Earth, revolves, and another word that describes that action is orbit. We orbit around the sun. As it orbits around the sun, that tilt will cause some places to become closer to the sun's light and heat energy. And let me just show you. As the planet rotates around, we see the tilt stays the same. Now, there's an X right here that says the United States. Now, it takes a whole year for our planet, to move around the sun, 365 days or 12 months. So remember what I said? There are 4 seasons. Well, each one of those seasons, that is based on the position that we are in relationship to the sun. Now, right here, if I back this up, this would be probably the season of summer, because the United States is right here, the sun is right here, and it's shining directly on that part of the planet that we live on. So we're getting a lot of the light and heat from the sun, so that indicates probably the summer season. But as we continue our orbit, then we kind of move away from the sun. We're still getting a lot of the light and heat, but guess what? We're not getting it very long. And we're a little bit further away, according to the angle, away from the sun. And that's what basically causes our season. Now, as far as an animal being affected by the seasons, I've got one little animal I want to show you. That's about all the time I have. This little animal is a 3-toed box turtle. And this 3-toed box turtle, I collected from the Post Oak Preserve, the forest across the road. And we have quite a few of them over there. But I can tell you right now, those that are still in the forest, guess what they're doing right now? Because they are members of the reptile family and they're cold-blooded, they don't deal with cooler or cold temperatures very well. So what they do, they burrow into the ground or in a hiding place, and they go into a deep sleep. And they will stay in that deep sleep, we call it hibernating or hibernation, until it starts warming up. Reptiles will do that live in nature. If the temperature gets cold, like in the season of winter, they go into deep hibernation, much like a bear, okay? Now, when will they wake up? Well, they will wake up when the next season comes, when it's warming up. You see, we move from winter into spring, right? So things will start warming up. And if you come out here in the spring and walking on the trail with me, we would be looking for some of these three-toed box turtles like Teresa here. Now, listen, guys. I have a granddaughter. She thinks she's an artist. And so basically I asked her, I said, will you do this for me? Can you draw me some pictures of some trees and make them look like they represent each season, how they would look in a season, certain season? Well, she started out with summer. And we can see there are a lot of green leaves on those trees, right? From summer, we enter fall, or the other name for fall is autumn. And we can see that some of the leaves are orange and red, and some of the leaves are beginning to fall from the tree. And then we enter winter. Now, there are no leaves on the tree. They have fallen off and they're all on the ground. Wow. So when will the leaves grow? In fact, tree looks dead, doesn't it? Well, it's not dead. The trees don't die that way. In fact, they're doing almost the same thing like animals that live in the forest, like Teresa. What they would do is go into a deep hibernation. Well, it's kind of like hibernating. They go into what we call dormancy. Now, when will they wake up and start growing leaves again? Guess what? In the spring. And in the spring, my granddaughter drew this, and she has little blossoms and a few leaves coming out. I actually like to call spring the growing season. Well, I've run out of time, so let me hurry up and get you guys back to Dr. Gorman. So if any of you have any questions, I bet he can answer them for you.
Thank you, Mr. Monroe. And we did have a question. The student wants to know, where did the name winter come from, since we're right in the middle of the winter right now? And actually, there's two different thoughts on that. One of them is that it came from England, and the other one is it came from Germany. But it really doesn't matter, because both of them mean the same thing. Both of them interpret as the wet season and the wet time, or the wet season. And that's because the winter time, a lot of times it's either raining or snowing. So it's wet a lot of times, especially in Germany and in England. And that is where we get the name winter from. And now Miss Ram is going to tell you about the moon.
Hey everybody, it's Miss Shram, and I am reporting here from the Johnson Space Center in Houston, Texas. So I am at a conference at NASA to learn all about space. So I'm so excited about today's topic, because we are going to be observing and recording patterns of objects in the sky, including the appearance of the moon. So today we're going to pretend that y'all are with me here in Houston at NASA, and we are going to be little astronauts learning about the moon. So we're going to have a lot of questions that we're going to answer, and we're going to ask together about the moon. So some of these questions include, how big is the moon? What is the moon made of? What does it feel like to touch it? What color is the moon? How far away is it? Why does it look different every night? And how come we can see it in the daytime? So you might have wondered some of these questions, and we're going to go over them one by one. So let's start with, how big is our moon? Well, the moon is about 1/4 the size of Earth. So if you look at that picture on the right, you can see the Earth is there, and then the smaller moon. Now, if you wanted to use real life objects that have the same relative size to each other, if you held a basketball in one hand, it would be like the size of the Earth. And then a tennis ball in the other would represent the moon. So that is their size relationship. How far away is the moon? It is 250,000 miles away. or 400,000 kilometers away. So that is really, really far. So when we send astronauts out into space to the moon, it takes about 3 days for the spacecraft to get there. So you can imagine those rockets have to go very, very fast to make it all that long way in 3 days. So what is the moon made of? So there's a lot of silly rhymes and children's songs about the moon, and people sometimes think that the moon looks like cheese. I don't know, what do you think? I see in that picture I showed you, it's yellow, it's got those big old craters, it kind of look like holes in cheese. But we know that the moon is not in fact made of cheese because we've sent people up there and we know it is made up of rock. So here are some pictures of the Apollo 11 moon landing in 1969. So this is the first time people made it to the moon. And there's famous astronaut Neil Armstrong, and he was the first man to walk on the moon. So over time since then, there have been 24 people that have visited the moon and 12 people that were lucky enough to walk on the moon. So when they were there, they were able to study what the moon was made of and what it feels like. So if you look at that first picture, you could see lots of craters and different textures on the moon, and those are caused by all the meteors and asteroids that have hit the moon over time. And actually, that's how scientists believe the moon was formed, from a meteor striking the Earth and a big rock breaking off, which is now our moon. So when astronauts were visiting the moon and they were doing their spacewalks and collecting soil samples, they had a lot of dust on their boots, and the dust was really, really sticky on their boots, and it was hard to get them to brush it off. So when they got back into the spacecraft, they were able to touch it with their hands. And a lot of the astronauts described it as kind of powdery, but also sharp. So those rocks and dust are really sharp. You can see some dust particles under a microscope at the very end, the last picture. And you could see all those jagged edges on the rock. And if you're wondering why are those rocks so jagged and sharp? Well, here on Earth, we have so much weather, right? We have rain, we have wind. In the winter, we have ice that freezes and breaks rocks apart. And all three of those factors, the water, the wind, and ice, all of that changes our rocks here on Earth. Those are cause processes that are weathering and erosion processes. Sorry, guys. So on the moon, we don't have that. So they don't have weather like we do. So where we have all those weathering processes that break down and change our rocks and smooth them out in space, they do not have that. So the rocks there are all jagged and broken. So it would feel kind of pokey and itchy to touch. So what color is the moon? Well, sometimes the moon appears to change color due to dust in the air or even during an eclipse. So the moon does not actually change color. It's always that kind of silvery gray color, but depending on what's in the atmosphere or if we're having an eclipse at the time, the moon can appear all sorts of different shades. So you could see it's kind of a warmer tan color, oranges, or sometimes even red. So that last picture is called a blood moon, and that's caused by a lunar eclipse. So can we see the moon during the day? You learned earlier that we can see the moon during the day, but you might be wondering, how is that possible? Usually you think of the moon being at night. Well, since the Earth is constantly rotating, sometimes the moon and the sun are above the horizon at the same time. So that way we can see the moon during the day. So the moon is above the horizon for 12 hours a day. The sun is above the horizon for 12 hours a day. And sometimes those 12 hours overlap. So we know every day we have 24 hours. So sometimes those two objects in the sky overlap. Sometimes they don't. So it just depends. Now, when you do see the moon during the day, it's a little hard because the sun is so bright, but a great time to look at the moon is always at night. We know that when we look at the sun's rays are so bright, they can damage our eyes, and we don't want to mess up our vision by looking at the sun. So a great time to observe the moon is at nighttime. We know that the sun is what's producing the light and the moon is reflecting back. So you can safely look at the moon in the nighttime. And when you do look at the moon, you might notice that at some points of the year, the moon looks larger. And you might be wondering, is the moon growing? What is going on up there? Well, no, it is not. The moon stays the same size, but depending on what time of year, the moon may actually be closer to us. So its orbit is not a perfect circle. And so that means sometimes the moon is closer to us and it looks larger. And sometimes it's further from us and looks smaller. So if you see the moon looking really, really large, that might be one of those times where the moon is closest to us. So this is a picture of downtown Dallas. You might have recognized some of the buildings or the bridge, and a super moon. So this was taken a few years ago, and the super moon is a full moon that occurs when the moon is closest to us. So you might have also noticed that sometimes it seems to change shape. Well, it's not actually changing shape, but the amount of the moon that's illuminated that is visible to us on Earth changes. So the moon changes appearance throughout the month. And this is called the phases of the moon. So depending on what we can see of the illuminated moon, it has different names for each of those. So this is caused by the moon orbiting the Earth while the Earth is orbiting the sun. So all three of those objects are moving and spinning and rotating. And so what we can see of the moon changes. So let's see a little bit more of an example. So we can see the sun all the way on the right. And here's the moon in different positions around the Earth. So you can see the Earth at the middle, and it has half of it is illuminated by the sun and the other half is dark. And we know that causes our day and night. Well, the moon is also illuminated on half of it. Half of it is illuminated and half of it is dark. So depending on where the moon is in relation to the Earth and the sun changes what we are able to view from Earth. So we're going to go over these different phases. And this is what we can see from Earth. So this is the perspective from outer space. And this is the perspective from Earth. So we can see at the beginning of the month, we have a new moon and the moon is completely dark. Then slowly over time, we're able to see more and more light. So that is called a waxing phase. It becomes brighter and brighter. Then once you can see the entire face of the moon, that is called a full moon. And then it begins waning. So that's getting darker and darker. The illuminated part gets smaller. So even though the moon is actually staying the same, what we are able to see changes. So the calendar actually reflects this. So our months are based on the moon cycle or the lunar cycle. So if you had gone out every single night last month in January and documented what you saw, you would have something like this. So the beginning of the month has a new moon. January 2nd was a new moon. It was completely dark. Then it was waxing all the way until the 17th when there was a full moon. It's at its biggest and brightest. Then over time, it was waning and waning and waning until tonight, which is the first night of February, where we will have a new moon. And so the moon on Tuesday, February 1st, will be a new moon. And then as we go into Wednesday and Thursday, that moon will start waxing again and getting brighter. So depending on when you're at this field trip, you'll be able to see a new moon slowly beginning to start the waxing process. And then my challenge to you is with a grown-up, take a look at the night sky and talk about what you see. So as you see that moon getting brighter, you can explain to your grown-ups how the moon is waxing. And then I had another calendar just to show you when the full moons are going to be in 2022. So the next full moon is going to be February 16th. So that's halfway through February. And it has a nickname of the snow moon. So that's going to be February 16th. And then, of course, I told you earlier, the super moon is when the moon is closest. That's going to happen in June and July. And then a lunar eclipse is going to be in May and November. So you can just look these up online. When are the full moons in 2022 or super moons or lunar eclipse? And I highly recommend you check those out, always with the permission and accompaniment of a grown-up. So that's all I have for you here. I'm going to send you back to Dallas for any questions and answers.
Thank you, Ms. Schramm. And there was a question. Do we ever see the other side of the moon? No, we always see the exact same side of the moon. That's according to science8.com. And now, Mr. Dominguez is going to tell us about the sun and the stars.
Hey guys, welcome to your virtual field trip, and today we are going to focus on this big yellow thing that is the center of our solar system. Our solar system consists of 8 planets, and here's our home right here. It's pretty easy to spot. It's the blue ball right here. It's the 3rd planet from this wonderful yellow star we call the sun, and this is where we live. That's our home. But we're not going to focus on the planets today. We are going to focus on this wonderful star, and we are going to talk about why it's so important to life on this planet right here, the 3rd planet from the sun. Hola amigos, bienvenidos a su paseo virtual. Hoy vamos a hablar de esta cosa amarilla que es el centro de nuestro sistema solar. El sistema solar consiste de 8 planetas. Y aquí vivimos aquí, en este 3er planeta. Pero hoy no nos vamos a enfocar en los planetas, vamos a enfocarnos en nuestra estrella, el Sol. Vamos a hablar de la importancia de este Sol para nuestro planeta Tierra y todas las cosas vivas que llaman a esta bolita azul su hogar. ¿Ok? Vamos a empezar con nuestro paseo. Let's go. Ok amigos, antes de empezar a hablar sobre la importancia del Sol a nuestro planeta Tierra y todos los organismos que viven en nuestro planeta, quiero hablar un poquito sobre el Sol. El Sol es el centro de nuestro sistema solar. El Sol tiene una edad de 4.6 billones de años, muy joven para una estrella. Nuestro Sol es la estrella más cercana a nuestro planeta Tierra. Y la Tierra gira alrededor del Sol. El Sol es muy caliente. El Sol tiene una temperatura de 10,000 grados Fahrenheit en su superficie. Alright guys, so before we get to talking about the importance of the sun to our planet and all living things, I wanted to give you guys some quick facts about the sun. The sun is of course the center of our solar system. It's the closest star to our planet Earth. We know that the Earth spins around the sun, so it has an orbit around the sun. The sun is approximately 4.6 billion years old, which may sound old, but it's actually pretty young for a star. And finally, the sun is pretty hot. At its surface, it's approximately 10,000 degrees Fahrenheit. Alright guys, so let's talk about why the sun is so important to all the living things that call Earth home. So I'm walking outside our beautiful EEC, and as I look around, I see grass, I see trees, I'm walking towards our goats and pigs, and without the sun, there's a couple of things that would happen. We wouldn't have light energy, and we know that light energy is crucial to the growth of plants. And why is that important? Well, without plants, we wouldn't have the food to feed these goats, to feed ourselves. So everything that depends on producers would die off. And next, we have the heat energy that the sun provides. So heat energy is incredibly important. I know it's been cold, but when you step out, you feel the sun's heat, and that heat keeps a lot of animals going. I have plenty of reptiles in my classroom, and without the sun, those reptiles that are ectothermic would die. So, the sun provides us with heat and light energy. That's why it's so important to us. All right, guys, I'm back inside, and I wanted to show you guys something pretty awesome. So let me see if I can get my friend out. He is a sulcata tortoise, a reptile friend of mine. Let's see if he'll let me get him. I just have to move a bunch of things around, and I'll tell you what those things are in a minute. So I've already explained to you why the sun is so important to our animal friends. Well, to all living organisms. Here he is. Here's my sulcata tortoise. He's adorable, right? What happens when the sun isn't available to you? Or what happens when you are a reptile keeper and you have to keep your friends inside because it's too cold? It's wintertime. So that sulcata tortoise over there can't be outside right now. So what do I have to do? Well, I have to have a setup that recreates the sun's both light energy and heat energy. So in this enclosure, I am faking the sun. The sun is so important to these animals that in order for me to be a responsible reptile keeper, I have to recreate the sun's power. So first, I have a heat lamp right here. So this lamp right here keeps my animal friend warm. And this other light over here recreates the light energy. So this is the heat energy from the sun. And this is UVB light, which is a type of light that the sun gives us. So in order for me to keep him responsibly, to keep him healthy, to keep him digesting his food, I need to have both of these things that recreate the sun's power. So the sun is so important that when I don't have it, I have to fake it. When it's summertime, he definitely goes outside, and I can't wait for summertime so he can be munching on some grass outside. But during the wintertime, I have to keep him in here, and I have to fake the sun's wonderful power. The heat energy and the light energy. Pretty cool stuff, right? All right, guys, I hope you enjoyed this virtual field trip. To recap really quickly before I let you guys go, we took a look around our environmental center and took a look at the animals that rely on the heat energy and light energy that the sun provides us. Without that big, bright yellow star, life on our planet would not exist. All right, guys, I hope to see you guys in person soon. I will see you guys next time.
Thank you, Mr. Dominguez. And we had a student that asked a question. Could we walk on the sun if we could get there? No, we could not. The surface of the sun is 10,000 degrees Fahrenheit. Here on the earth, we think 100 degrees Fahrenheit is pretty hot. So no, we could not walk on 10,000 degrees. We'd melt before we got anywhere close to it. Okay, and now I'm going to share my screen. Okay, during this virtual field trip, students observe and describe patterns of objects in the sky, including the appearance of the moon. Ms. Ramirez told you about the day and the night. Mr. Monroe talked about the seasons. The moon was discussed by Ms. Ram, and Mr. Dominguez told you all about the sun and the stars. Thank you for joining us. If you would, teachers, go to www.tiny.cc/pk-2 feedback. Fill out a very short form and send it in to us. We would appreciate it. Thank you. Stay warm.